So today we need to talk about different families. So let's get through this. And I first want to start off by talking about, in chemistry, what a family is. And when you look at the periodic table, the columns are called families. And I would say that elements that are in the same family or I could use the term group because group or family is really one and the same. They're going to have similar properties and similar reactivity. So if you have elements that are in the same group or family, they're going to act the same. Okay, so looking at the periodic table and throwing this in there, I would say that going up and down, like you see right here, you would have elements that are in the same group or family. Well, no, I'm saying that group or family is the correct word. It's either or, group or family. Okay. And these would react the same. So I guess we could say that sodium, Na, would react a lot like potassium. Aluminum would act a lot like boron. Now would lithium and beryllium, would they act the same? But lithium would act the same as sodium, as potassium, rubidium, cesium, and francium going all the way down. Make sense? It's the reason the term family is used is because if you think about like your family, you act a lot like the members of your family too. Right? You have the same properties as them, at least. Okay. And just like you, where you have a family name, well, these have a name too. So I want to go through and name these families. The first family, the first group, is called the alkali. A-L-K-L or K-A-L-I. Alkali metals. Oh yeah. Oh yeah. This is your periodic table.
Alkali or alkali?
Alkali.
Okay.
Alkaline is the second group. Groups 3 through 12, which is going to be this point through this point. These are collectively known as the transition metals. Do what? Then we really don't worry ourselves too much about any of the other groups except the last two. So I'm at group 17 now. Group 17 is known as the halogens. And group 18, the noble gases. So, it's kind of a review piece. I would remind you that A, T, I, B, R, C, L, and F, all of these that are in this group are all considered to be halogens. Noble gases, the very, very last group. Good? So these all act the same. Fluorine, chlorine, bromine, and iodine are going to act all the same. Beryllium, magnesium, calcium, strontium, barium, and radium, they're all going to act the same because they're in the same family. Good? Okay. I want to move on to a different topic now, and the next topic that I wanted to describe or talk about is this concept of valence electrons. Valence electrons are going to be electrons that are in the outermost energy level. In the outermost energy level. And they're going to be responsible for chemical bonding. So to draw out a picture of an atom so that you can see this, of course, you know there's the nucleus in the middle. You've got all of these levels of electrons. That this was described by Bohr. That's a reminder from yesterday's lecture. And now I'm saying that wherever that outermost level is, that would represent your valence level. So in the case of the atom that I have drawn here, your valence electrons would be in this level, the outermost level of electrons, the furthest orbit from the nucleus, from the center point. And the big rule of chemistry is that all atoms want 8 valence electrons. It's a huge, huge, huge piece of this class. Everything wants 8 valence electrons. The problem is that not everything has 8. That means that there's going to have to be some chemistry done to facilitate the need of these 8. So, to re-summarize that statement, atoms want to have 8. They may not have 8, so they will do something to obtain what they want. So that's why we would consider the noble gases to be inert. You want to add that off to the side. Inert means that they don't react. They don't need to. They already have their 8. Now let's think about a noble gas real quick, like fluorine. How many electrons does fluorine have in its valence level? 7, right? How many more does it need? So fluorine is going to gain 1 electron. Now when you gain an electron, you're gaining a negatively charged particle. That means that fluorine would exist as a -1 charge. So what we need to talk about real quick is we need to talk about this concept called the oxidation number. This is the charge an element will take as it gains or loses electrons. Okay? So I'm going to show you your oxidation numbers, and I'll put them in red on the periodic table. And this is a really, really pivotal part, so please be watching closely. The guys in this first column, their oxidation numbers, their charges are going to be +1. The second group, +2. The reason they'll be +2 is because they're losing 2 electrons, or losing 1 electron in the alkali case. +3. Kind of makes sense gone along with what we've got. But number 4, the carbon group, brings up something a little bit different. This is plus or minus 4. And then nitrogen. How many valence electrons does nitrogen have? 5. How many more does it need to get 8? So this actually is going to be a -3 charge for the nitrogen group. Oxygen has 6, needs 2 more, so that's going to be a -2. -1 for your halogens, and of course for your noble gases. They would be 0 because they're not gaining or losing electrons because they're already inert. They're neutral. No charge. So sulfur. What should sulfur's charge be when it's doing chemical reactions? -2, right? What about the charge on calcium? Should be +2. Sodium, what should its charge be? +1. Phosphorus, what should its charge be? -3. So you've really got 2 items working for you. You've got this fact that I can count valence electrons, or this fact that I can count the oxidation number. How many electrons does it have? And what's its charge? Good? This line is kind of already darkened on your periodic table, so I'm really just kind of emphasizing it. We've mentioned this before, but anything to the left of this line, do you remember what it is classified as?
Metal.
Very good, metal. So I think we could write that to the left of your line, you have only metals. And to the right of this line, you have nonmetals. So that means that any of these guys over here, that I'm pointing to right now, they're all going to be nonmetals. Everything to the left of this, though, is going to be metallic. Now, based on the oxidation number, what can you tell me seemingly is the charge of most nonmetals? Are they mostly negative or positive? So nonmetals would actually be losing electrons. So metals will typically lose electrons. To become positive. The term that describes them is cations. Good? So lots of information on your periodic table. Lots of information in your notes.